Hello all, once again, welcome to Physi Dive. Today we are going to study a very important topic, that is why we are using dimension analysis in our daily life and what is the importance, and is it is completely flawless? No, there are some limitations too. We'll study that too in this session. So welcome once again. This is your teacher Alexi Rajan and welcome to Physi Dive. So let's dive into the class. So, what are the uses of dimension analysis? There are mainly three uses in dimension analysis, and the first main use is that conversion of one system of unit to another system of unit. So we have different types of system of units in our physical world or physics in measurements. That is, for example, MKS system, CGS system, and all right. In MKS system, the mass is kilogram, the unit of mass is kilogram, and this length is meter and time is seconds. But in CGS system, the unit is gram, unit of mass is gram, and unit of length is centimeter, and then the coming to the next thing, time, it is same as that in MKS, that is second. So we have seen all these things, and you can go through the textbook and see the various system of units. Now, the main use of this particular conversion or one system of unit to another system of, okay, let's see how we can do that. There are mainly three uses for this dimension analysis, and the first and foremost use is that conversion of one system of units to another system of units. We know that various system of units are there in physics, in measurements and all. And for example, MKS system is one system of unit and CG system is another system of unit. In MKS system, the mass has a unit of kilogram and length has a unit, SI unit of this meters, and time as an SI unit of second. Whereas in CG system, mass has the SI unit of the gram as its unit, and whereas this length has a unit of centimeter as well as time has a unit of seconds. That means for various scenarios we are using different types of units there. In when you go to Europe and all, the weight is mainly measured in pounds and all. You can see that it's FPS system of units. So there and all, it varies according to the scenarios and the places where you are using this particular measurements. So that is one thing. So we are going to convert one system of unit to another system of unit using this dimension analysis. Very simple. So let's see how we can do this thing. Okay, let us see. A physical quantity x can be defined as nu. So what is this thing? X is the physical quantity. N is a number and U is a unit. You already know that thing, how you measure a thing. You measure a thing on the basis of a standard unit. That means how many times that unit is coming in that particular measurement. For example, if I am taking 1,000 meters, that means 1,000 times a meter is coming in that particular measurement, and that is 1 kilometer, right? So there, that meter is a standard measurement. So you can see that thing, a physical unit can be said, or if I'm saying 1,000 kilometers, then that particular, if this is 1,000 kilometers, then this particular measurement is comprised of a number, that is n, and a unit kilometer, that is u. So you are saying that a physical unit is like this. Or simply, I'm not going, I'm saying 1 kilometer. 1 kilometer. That would be better. If this is 1 kilometer, and I'm saying 1 is this number and kilometer is this thing, right? So this both term will comprise of this physical quantity. The same way, if I am saying that instead of saying 1 kilometer, I am saying 1,000 meters. 1,000 meters. Will there be any change? No, there won't be any change. It will be same, right? You all know that thing. 1,000 meters is equal to 1 kilometer. That means physical quantity is same. Here also the physical quantity is same, but the number has changed here to 1000 and unit has changed to meter, even though both physical quantities are same. For example, if I am saying that both are equal, these both things are equal, so I can say N1 U1 is equal to N2 U2. I hope that you got the point. Or simply N2 U2 is equal to N1 U1. N1 U1, right? From there, if I want to convert one system of unit to another system of unit, I need to find out this number N2. So N2 is equal to N1 U1 by U2. N1 U1 by U2. We'll just do one example, some mathematical equations, then we'll understand it more clearly. Convert 5 joules into erg using dimension analysis. So joule is in MKS system, whereas erg is in CGS system. So both are units of what? Work or energy. But we need to convert 5 joules to erg. So we'll see how we can do this thing. So you all know that thing. The dimension of work or energy is what? Is ml square t raised to minus 2. This is the basic unit. Now, I'm saying that we know one very important thing. N1 U1 is equal to N2 U2, or N2 U2 is equal to N1 U1, right? So I am saying that this N1 is nothing but 5. It is 5. And U is a unit. Unit in dimension form is what? ml square t raised to minus 2. It won't be changed. It won't be changed. So we can say that thing. It is m l square t raised to minus 2, right? Now, a very important thing, divided by U2, this is M1, L1, T1. Now, if I want to just take N2, then that would be 5 into M1 by M2 raised to 1, L1 by L2 raised to 2, T1 by T2 raised to minus 2, raised to minus 2. This is the case. Now, we need to see that thing. Now, M1 is in MK system, and M2 is in CJ system. And simple, M1 is larger quantity, right? Larger quantity means the unit is larger, right? Bigger one. So there we can say it is 1000 M2 by M2. Why I said 1000 M2? Because 1 kilogram is equal to 1000 gram. So instead of writing that kilogram, I just convert that thing to CGS, that is gram. Next, L2, that is 100 L2 will be equal to L2 divided by L2, and you can see that thing 100 means 100 meter, 1 meter, or 100 centimeter is equal to 1 meter. So you will get that thing. And in this case, 1 square is also there, raised to 2. And now time in both cases, they are same, are equal, is second only, so they cancel out each other, now raised to minus 2. So more precisely, you can just write this thing in a different way, that is five into 1000 gram divided by gram into 100 centimeter divided by second 1 raised to 2 raised to minus 2. 5 into 10 raised to 7 erg. So you have seen that thing, 5 joules is converted to 5 into 10 raised to 7 erg. So this unit is in MKS system and this unit is in CGS system. So you had converted MKS system to CGS system. So I hope that you got the point how you had converted. You had converted simply by a simple equation, that is funda is like this, that is N1 U1 is equal to N2 U2. From there N2 is equal to N1 U1 divided by U2. From there you just convert that units into corresponding units, cancel out the units and you will get the answer. So this is how you just convert one system to another system. Now another question. Find the value of, just pause your video and just read the question carefully, write it down, try to do yourself. Now I'll just help you out in this thing. Find the value of a force 100 dyne on a system based on a meter, kilogram and a minute as a fundamental unit. So this is the question. So you want to find out a force. What you want to find out? The force, right? The force is the thing. So what is the dimension formula of force? Equal to ml t raised to minus 2. This is the dimension, right? This is the dimension. So here this question seems to be very easy, but there is a small problem in this thing. We will see what is the problem. Okay. F is equal to ml t raised to minus 2. So you want to convert 100 dyne to a system. I don't know what is the name of that system, but that system has based on, this system is based on what? Meter, kilogram and minute. It's not second, that system is based on minute. So how can we convert this thing? Okay, it's simple thing only. Just we will do this conversion. That is N2U2 is equal to N1 U1. Now C is the case, right? Okay, fine. Now M1, this is 100 dyne. So definitely dyne means it's in CGS system. So it will be in gram. So it will be in gram, right? And divided by, what is that? It is kilogram, right? M2 is kilogram. Now L2, in dyne it will be centimeter, whereas in this particular new unit it is meter, right? Now in T1, in CGS system it is second, but here in this new unit it is minute. Here is the difference. That is 3.6. So let us move to the next session, that is checking the correctness of the physical quantity. This is the second main use of this particular dimension analysis, how we can check the correctness of physical quantity. Here comes a very important term, that is homogeneity principle. Homogeneity principle states that in an equation, if you're finding two or more terms, then if you're doing the dimension analysis, then you should get the same dimension formula for each and every term. Then only we can say that particular equation is correct. For example, if in the question, check the correctness of equation, that is S is equal to ut plus half at square. S is there, ut plus half at square is there. So here you are having three terms there. One is S, that is a displacement. Second term is ut, and the third term is half at square. These are the things, right? So you want to find out the checking. If you need to check the dimension, if you need to check the correctness of the equation, then you need to take the first term, second term, and third term, and then check it individually. So S is nothing but it is a displacement. So you know that thing, the dimension it will be L. Now, if I'm just taking the second term, then if that is U point L. So the second term is also same. Now to the third point, that is half a t square. In dimension, we'll not take the constant, we'll just leave this constant and we'll check the variables here. So a means what? Acceleration. So L t raised to minus 2, t square is t square. So here t raised to minus 2 and t square both will cancel out each other and the remaining will be L. So you can see that thing in S is equal to ut plus half at square, you are getting the same dimension formula for all the three terms in an equation. So three terms, by saying three terms, what I mean? I mean the terms which are separated by this plus sign, minus sign and the equal sign and all. So this is about this dimension correctness, or how to correct the correctness of a physical quantity or an equation. Now the next question, it's for you. Check V is equal to root 2 gm by r. You will study this equation when you come to the particular chapter, that is gravitation chapter, that you will study this thing. This is the velocity V is equal to root 2 gm by r. So how can I check the correctness of the equation? So let us see what is this thing. So here V is velocity. So it is what is the equation? Dimension formula. It is L t raised to minus 1. That is dimension formula. So LHS is this. So if I'm taking the RHS, then I need to find out, I should get L t raised to minus 1. So let us see what is this thing. So RHS is equal to root 2 gm by r, which is nothing but 2 gm by r raised to half. Okay. Now, in this case, g also have a dimension, m also have a dimension, and r also have a dimension. Even though g is a capital, or it's a constant, universal gravitational constant, it do have a dimension. So what is the dimension of g? Let us find out that first. So you know that thing, g is F is equal to g m1 m2 by r square. This is the gravitational force equation. So okay, no need to worry, we'll study this equation also in details in the coming classes. So from here, g is equal to what? F r square by m1 m2. From there, g is equal to, what is the dimension formula of force? M L t raised to minus 2. R is what? Radius. So radius represents length. So L square divided by, what is m1 and m2? It's masses. So we can say kilogram. So it's not, there's no need of writing kilogram. M square. From there, we'll get a point, that is, if I'm taking this m to the upside, denominator, the m which is in the denominator to the upside numerator, it will become negative sign, and plus 1 is there. So you'll get raised to minus 1. One L is there, one L square is there, L raised to L cube, next one t raised to minus 2. So this will be the dimension for universal gravitational constant. So let us see that this is m raised to minus 1, L cube, t raised to minus 2. Okay, what is the dimension of m? That is mass m. Now what is the dimension of r? It is length L. So that's the case. Now substitute all these three to this particular main equation. Then what will you get? Then you will get RHS is equal to, you're not taking the constant there, we'll just take away the constant. So g will be m1, m raised to minus 1, L cube, t raised to minus 2. Okay, and one m will be there, divided by L. From there, you will get the point, that is raised to half is also there. Okay. So this m and this minus m raised to minus 1. So they will cancel out each other. It's not cancelling out. They will say m raised to minus 1 plus 1, that is 0, that is 1. And now remaining is L cube. So L cube, and downside one L is there, so they will cancel out, and then one L square will be there, and one t raised to minus 2 will be there, raised to half, raised to half. So here comes a beauty of correctness using the dimension formula. So raised to half means definitely this will become L t raised to minus 1. So you got the point, that is RHS is equal to L t raised to minus 1 and LHS is equal to L t raised to minus 1. So obviously the equation is correct by using dimension analysis. So I hope that you got the point there. You just take each and every terms in an equation and find out the dimension formula, and you will get, if you're getting the same answer, then so far so good, it is correct. So that's all about the correctness of the equation using dimension analysis. Now the third use of dimension analysis is to derive relationship between the various physical quantities. So if you have two physical quantities and you want to find out what is the relation between these two physical quantities, then you can use this dimensional analysis. So, but one very important thing is there in this particular usage, that is you need to know about the basic relations. For example, we'll just deal it with an example. You will get it more clear while doing this particular problem. Okay, so in this problem it is given that the oscillation of a simple pendulum is dependent, or it depends on various attributes. For example, mass, length of the string, acceleration due to gravity, and angular displacement. They are saying like that. So we know these things because if you are taking a simple pendulum, just say that, okay, you have a simple pendulum here, and it is mounted on a stand. So this is a simple pendulum, and this is a bob. It is oscillating, then definitely it oscillates like this, and then it will oscillate to like this. So there will be an angle theta formed here. This is the angular displacement there. So from this scenario, we can say that the time period, because its oscillation is there. So obviously time period depends on mass, now length of the string, then acceleration due to gravity, because it's oscillating, it will definitely stop because of that gravitational force. So definitely acceleration due to gravity will be there, and theta. So these are the various physical quantities which contributes to the time period of the simple pendulum. We know this thing. Okay, from the scenario we got this thing. But this is not actually correct because we don't know what is the power raised to this particular physical quantities. For example, we are just giving certain powers A, B, C, and D. We don't know the values of A, B, C, and D. But if we are going to find, if we find out the values of A, B, and C, A, B, C, and D, then definitely you will get a relation there. And you know that thing, this is a relation, so definitely this is proportionality sign. So in order to change that proportionality sign, definitely T will be equal to some constant. We don't know the value of constant. M raised to A, L raised to B, G raised to C, and theta raised to D. This is the case. Now using dimension analysis, we are going to find out this thing. So by dimension analysis, LHS, T, the dimension of T is what? T itself, right? It's a fundamental physical quantity. So definitely fundamental unit T is there. That is equal to K. Now I'm putting this K here. Okay. Now M, dimension of M is M itself raised to A, L itself, L raised to B, and G, that is acceleration. G is what? Acceleration. G is acceleration definitely. So it will be L t raised to minus 2 raised to C. And then theta. Theta is what? Theta is angular displacement. It's an angular displacement, and for your knowledge, there is no dimension for theta. Angular displacement, there will be no dimension, because if I'm just taking an arc, these all are basic things. So if I'm just taking an arc, then theta. So theta is given by arc by radius. Arc by radius. What is the dimension of arc here? R represents length. So L by radius is what? L. So L by L, that is nothing. So it is dimensionless quantity. So we don't need to take that theta in this particular scenario. So T is like this. So if I simplify, then definitely I'll get m raised to 1, m raised to a, m raised to a, L raised to 1 C is there and 1 B is there, B plus C, and T raised to minus 2 and 1 C is outside. So definitely this 2 C, that is minus 2 C will be there. That is equal to T. This is the case, right? Now we are going to equate LHS and RHS. What? Minus 1 by theta is not in the picture. So that's a case there. Now I am going to substitute these values here. Then I'll get T is equal to some constant into M. A is equal to 0. L, B is what? 1 by 2. G is what? C, G raised to C. C is what? Minus 1 by 2. And there is no requirement of this theta. So we don't need to write that angular displacement. Here a very important and an interesting fact is there, that is there is no dependence on mass. This is in the case of simple pendulum and for small amplitude. So there is no dependence on mass. So we don't need to take this mass. It's a very good thing and a very interesting fact, that is the time period doesn't depend upon the mass, even though we feel that mass will have some dependence. Okay, so T can be written as K into root of L by G. That's the case there. Go with another. So this is your turn that to find out what is this case, how you will solve this particular question. That is the wavelength the wavelength lambda associated with a moving particle depends on its mass, velocity and Planck's constant. These all things are given there. That is the wavelength associated with a particle depends on mass, velocity and Planck's constant h. But here it will be incorrect unless you put A, B and C. This is the case there, right? Now, simple thing. In order to change this proportionality sign is equal to K. I don't know the value of K. So is equal to M, A, V, B, H, C. So lambda is what? Wavelength. Wavelength is associated with length. So obviously it will be L. LHS will be L. Now K, M, mass is equal to M. That is this way. A into velocity is what? L, T raised to minus 1 raised to B, and Planck's constant h. We need to find out. How we will find out the Planck's constant? Even though it is a constant, it do have a dimension. So definitely you need to find out the dimension here. From how you will find out the dimension. In Einstein's photoelectric effect, we know this equation E is equal to h nu. E is equal to h nu. From there, h is the Planck's constant E by nu, right? So energy by nu. So obviously nu can be written as one more thing in a different way. We can write it is 1 by time period. Nu is frequency, so it is 1 by time period. This can be written as E 1 by time period. So it will go upside. So E T. So energy M L square T raised to minus 2 into T. So from there you will get the value M L square T raised to minus 1. This is the case. So you will get M L square T raised to minus 1 raised to C. Equate the values. So you will get A plus C is equal to 0, B plus 2C is equal to 1, minus B minus C is equal to 0. This is the case, right? Now you need to find out the values there. So this you just rearrange. So this is your work, and you need to find out the equation for lambda by uh, by using this dimension formula, and just do comment the answer in your comment section and then get the point. There are certain limitations for this particular dimension analysis. The first and foremost limitation of dimension analysis are the constants. The constants. We don't know the constants. That means it is not applicable to any of the constants. So dimensionless constants are not involved. We cannot find out. In the previous case also, we had seen that is one case there, but we don't know. The time period of simple pendulum is some constant root L by G, because we are not dealing with the constants here, dimension, especially dimensionless constants. We are dealing with the dimension, the constants which have dimension, but this the other way around in the case of dimensionless constants. But we'll get a relation there. Okay, that is one reason, one limitation. The next and very foremost limitation is that it is always not true to correct, or this correctness using this dimension analysis will not be always true. For example, S is equal to ut plus half at square. So if you're finding out the equation, if you're correcting the equation using dimension analysis, then you will get the correct value, because if you're taking S, dimension of S, ut and at square, then you will get the correct value, equal. And now you just see this equation, ut plus at square. If I'm neglecting that half and I'm writing this thing, here also you are getting the correct values for all the three terms. It means if you're going with dimension analysis, then this equation will be correct. But in actual form, it's not correct. So there are certain limitations. For vague purpose, we can use this dimension analysis, but this is the other way around. So always it will not go good in the correctness of the equation. And the third one is that we are not getting a correct idea about the logarithmic functions, exponential functions, and the complex quantities, trigonometric functions involved in a physical equations or physical quantities. So this is a very it's a big limitation there. So because if something is related, if some quantities are in some quantities, if exponential, trigonometric functions or logarithmic functions are involved, it will be very difficult for us to calculate the values and all. So obviously the dimension analysis have a huge limitations there. So that's it. So make sure that you go through the video chapters and see what all things you can do, and make sure that you pause the video while doing the numericals, and we'll do numerous number of numericals there, no need to worry. And that's it for today's class. So stay tuned, and we need your support. That is you like, share and comment and subscribe the channel. So we'll see you in the next class with a new topic, that is accuracy, precision, errors, in the first chapter, first unit, that is units and measurement, chapter units and measurement. So that's it. See you in the next class. Bye.